we will first be measuring the volume of a marble. For the volume, we will be needing the diameter of the marble, which can be measured using a pair of vernier calipers. The vernier caliper has a precision of 0.1 millimeters, and a precaution when using it is to check and correct for zero errors. As shown in the picture, the zero error for this pair of vernier caliper is 0.0 millimeters. With this, we will be measuring the diameter of the marble. We will take 3 readings and calculate the average value to improve accuracy, as the diameter of the marble might not be uniform throughout. Next, we will be calculating the volume of the marble by using the formula for the volume of a sphere, 4 divided by 3 times pi r cubed. The volume of the marble turns out to be 1910 millimeters cubed, corrected to 3 significant figures. Next, we will be measuring the mass of the marble. When using an electronic balance, always remember to press the re-zero button. The mass of the marble is 7.3 grams. Using the formula density equals to mass divided by volume, we will now calculate the density of the marble, which is 0.477 grams per cm cubed, corrected to 3 significant figures. The next object will be a fork. The apparatus needed are a measuring cylinder and an electronic balance. Because the fork is irregular, so we will need to use the displacement method to find its volume. Firstly, the measuring cylinder has a precision of 1 milliliter, and a precaution when using it is to read below the meniscus when measuring the volume of water. The initial reading is 60 milliliters and the final reading is 61 milliliters. Therefore, the volume is 1 cm cubed. Next, we will measure the mass of the fork using the electronic balance, which is 9.9 grams. Then we will be calculating the density of the fork using the formula, which gives us a value of 9.9 grams per cm cubed. The last object is a 30 cm ruler. The apparatus needed are a meter ruler, a pair of vernier calipers, a micrometer screw gauge, and an electronic balance. The 30 cm ruler is an regular object. The meter ruler has a precision of 1 mm, and a precaution is to look directly above to avoid parallax error. The length of the 30 cm ruler is 31.3 centimeters. The breadth will be measured using a vernier caliper, which gives us a value of 30.0 millimeters. The micrometer screw gauge has a precision of 0.01 millimeters, and a precaution similar to the vernier caliper is to check and correct for zero errors. The zero error shown here is 0.00 millimeters, and now we will be measuring the thickness of the 30 cm ruler. Similarly, we will be taking 3 readings and calculating the average value. Now, we will need to calculate the volume of the ruler given by length times breadth times height. We substitute the values in, which that gives us a final value of 17,090 millimeters cubed, corrected to 4 significant figures.
Lastly, we will have to measure the mass of the 30 cm ruler, which is 23.7 grams. Finally, we will calculate the density of the ruler using the same formula. The density turns out to be 1.39 grams per cm cubed, corrected to 3 significant figures.